see my slides because I wrote them yesterday over like 20-minute period of time, so apologies. So how many of you guys are hardware developers? I just want to try to see this. Okay, so 10, 15 people. How many people develop or want to develop things on Arduinos or create devices or create something that might actually be not software, but software and hardware? So cool, a lot of people, like more of the audience. And so Helium kind of is a company where we're trying to enable this world. And so like I said, my name is Carey. Actually, my actual Twitter and GitHub are both Denz1. The actual iconography died, so I couldn't make that work. So let's go on to the next slide here. So what is Helium? I'm going to have to actually read this, and let me know if you can't hear me, because I know the sound is a little bit off. Helium is building physical infrastructure that makes it painless and cheap to get smart devices online, exchanging data without being tied to complex hardware components or protocols. So essentially, we're trying to create a network that allows devices to connect that wouldn't normally connect to the internet. Let's see here. A lot of people have heard the term Internet of Things, I'm assuming. Hands for Internet of Things. What we like to call Internet of Things, call them things on the internet. Yeah, there's a whole world. People have been doing this for 25 years, right? So the idea that the Internet of Things term came out in the last couple of years is kind of, just based on the fact that there have been people in basements and in laboratories and in companies building ways to connect to the internet for a long time. And we're essentially building technology to put things on the internet. So our history, I just skipped that. Our history, so we went into business about 10 months ago. We started with 3 software engineers. We knew nothing about hardware design. We've grown to about 10 employees now. And other than Mark, who's kind of sifting around here somewhere, we're about 9 engineers and 1 business person. The original idea was to use off-the-shelf components, create metropolitan mesh networks. Have any of you heard of XB or Synapse? Okay, or XB, yeah. And so those are great technologies. One is, and they all kind of use the Zigbee standard. It allows you to mesh or connect your devices together. One of our other business ideas was to write a cloud application that can trigger external API calls. And of course, the third bullet point was we wanted to conquer the world of sending small amounts of data in city infrastructure and actually getting that connectivity going. So this died. So let's see here. Okay, there we go. Oh, here we go, let's back up. All right, so the first thing I got was good luck creating a mesh network that big. So the idea, what we originally thought about was we wanted to create massive mesh networks in cities and metropolitan areas. And one thing that we figured out really, really quickly is that it wasn't possible. So what did we evolve into? We wanted to use existing silicon standards. We wanted to create a protocol that is simple and effective. We wanted to inspect the information that is being sent around like your firewall. And we wanted to create a layer of expressiveness in our network. And we wanted to conquer the world of small data, 1 CD at a time, just like the original idea. Let's see here. OK, so the first step we made was one thing is we spent about 3 months when we started the company figuring out if we could actually build these things with off-the-shelf components. We wanted to build these networks that could handle data, that could allow people to intercommunicate through the world. And oh, they're closer? I'm sorry. Cool. Appreciate that. It sounds loud from here. So one of the things that we figured out was we came to the conclusion that off-the-shelf hardware couldn't solve all of our problems. We couldn't create multi-tenancy. Has there ever been a multi-tenant radio-based network on the planet? Other than Wi-Fi, of course, it's still not multi-tenant. One of the things that we figured out is a lot of these solutions, they actually create very, very vertical problems, or they actually solve very vertical problems. So what we did was we scoured the internet for people that have done similar things, and one of the things we noticed that a lot of these things have been evolving a lot longer than Internet of Things. And we actually found engineers that were upset about the Zigbee standard. And one of the things about the Zigbee standard, it is an open standard, but it's closed by almost every software creator out there. So there are some open Zigbee standards, but there was just no mechanism for creating this open interoperability. And actually what we did is one of our vice president of engineering, I called him at his house. I found him in the white pages. And he actually had a Kickstarter called Radio Blocks. I don't know if anyone's ever run into that before. There's a company called Colorado Micro Devices. And we actually found Eric Onosky through the white pages, and we saw his vision about device interoperability and communication, and we found him and we brought him into our business. So here's kind of a base slide of our architecture. We want to be able to support millions of devices in metropolitan areas, have bridges, and actually have an expressive routing layer that can actually communicate over IPv6. One of the things we want to do is we want to make this network grow and become this global interoperable network. So imagine if you had a doctor that was in Tokyo, and that doctor was the greatest heart doctor in the world, and there was a child in San Francisco that could actually, that was connected to an EKG, and it could send data over the internet and actually connect and become enabled by these devices without any configuration at all. And this is kind of one of the ideas behind what we're doing. Let's see here. It's not switching. Okay, so a few things that we create. We create modules that can fit into almost any device. Actually, Mark, do you want to pass around a few devices? So this is actually one of our network bridges that we're using, and these bridges can be placed in metropolitan areas, and they speak at about 4.25 miles line of sight, and at 900 megahertz they speak at roughly 10 miles. And the idea is we wanted to make it so cheap that your pet rock could literally connect to the internet and update its Twitter account. We want to make it so thousands and thousands of devices can connect to the world and intercommunicate, and that's kind of the ideology behind the business. So we've done that through creating modules and creating bridges, and you see there, this gentleman's holding an Arduino shield.
I'm having a heart attack.
Helium creates network bridges that can service thousands of concurrent connections. So the gentleman that's holding this bridge right here, that bridge can service about 64,000 active devices. The idea is we want to be able to support millions of devices in a city and not have it cost a lot of money. And that's the core concept of the business, being cheaper than mobile. Let's see, slide. Okay. We create routing infrastructure for public and private data. So if you want to send data to the internet and it's expensive and you can't afford it, we'll do it for free if it's public. If you want your data to be private, then it costs money. It's something that we actually charge money for. Where's the, okay. So the deployment model, so how do we plan on creating this network, this large system? Let's see. The first thing is we want to deploy primary bridges in cities. These are hosted by and paid for by Helium. These bridges are on top of buildings and they create the core network, but they don't create complete coverage. We have secondary bridges that are hosted by municipalities and other trusted organizations. These bridges end up on light poles. They create a reason for a city to want to use us. So we want to create traffic monitoring systems, environmental monitoring systems, things like that. But we want to enable these systems, and we want to enable people to be able to send this information back. And one of the ideas is we want to get people to want to use our network to just send data back to the world and then figure out all of the other more complex things like how do you make money later. But it's more about how to get that information back to the world. And then we have tertiary bridges. Tertiary. There we go, one more. This is secondary, right? Matt, where do I point? All right, there it is, tertiary bridges. So Helium, so that device that the gentleman in the purple shirt has, that can actually be a base station in the house. It can be this system that any manufacturer can use. It's completely, it doesn't handle any code at all. It's an actual bridge. And it sends frames to the internet, And the routing layer at the internet actually figures out what that does. So customers that have tertiary bridges in their homes, they can actually share that connectivity through other devices. So how hard is it to send a message through Helium? This is a C example of how you would send, basically saying I pressed a button. This is, how many Arduino people do we have here? So you've probably seen this as the first example of an Arduino, and this is how you would actually press a button in Arduino and say, hey, I pressed this button. This is how you would send that through Helium. And the idea is that that would actually make it to the internet, and that could get processed by the internet after that. Has anybody studied Node-RED? Okay, we got one Node-RED guy. So what we did recently was we actually forked Node-RED. It's a product created by IBM, and it's something for it's basically was a tinkerer's tool for creating flows and actually being able to visually map information through the internet. We took Node-RED and we made it multi-tenant. We made it secure and we made it reliable. And if you've worked with Node-RED, you might know, like, right now data is stored on the file system. There's no sense of a login. There's no sense of multiple users. We've taken all of that and we've made it integrate directly with Helium, and it works as one homogeneous system. All right, security. Oh, it is scary as hell. So one of the things we did was we actually found a competent. I want to skip that slide every time. Wait, there it goes. Okay, there we are. So we found a competent security firm, right? We wanted to make sure this stuff was secure. We didn't want to just create a project or a product and then have people wonder what the hell was going to happen after it was deployed, right? So we spent a lot of time actually thinking about security. One of the things we did was we found a great security. It's called Coalfire. It's a really, really good firm. And we got their best, they're the best of the best there to work on it. And one thing that we didn't do is we didn't worry about writing any code about the actual security code until we had somebody review the process and the design of our work. The other thing is we're not putting this application out to the public without real security built into it first. Let's see if this one goes. Okay, so this is Jerry Irvine from Prescient Solutions. One of the first things he said is about IoT and Internet of Things is, truthfully, security is scary as hell. That's one problem that we're really trying to solve and do really well at. So let's talk about things we've learned. Hardware design takes time to get right. It's not like software where you can just, I found a bug, or I'm trying to cast a string to a Boolean, and you have to try to get it right. You have to factor in every cost, down to the USB cable, to the connectors, everything. Yeah, you need to buy the right tools, but not the most expensive ones every time. And obviously you can rent what you can't afford. So we have spectrum analyzers that we pay $900 a month for, but they're probably $50,000. If one day we'll be able to buy them, hopefully. One thing we've learned is you don't need 20 megabits a second for your trash can sensor. So most of the folks that we talk to just want to send very, very small pieces of information. They want to send less than 100 bytes of information. That's what we're trying to capitalize on. We're trying to build a system where you can talk at very long range and send very, very, very little bits of information and not have to have this giant thing with a compressor on the side of your building that has to handle your information. Embrace small data. There are protocols in the world where it doesn't have to be JSON or XML, and it's much, much smaller. But it still, at the end of the day, ends up like JSON and XML. Work with that information. Don't send 40-byte UUIDs on every request. Every byte counts when you're trying to build small networks for small devices. So what's next for Helium? We're recruiting alpha candidates. We have a bunch of Fortune 500 companies and some tinkerers in the pipeline. But we're giving out Helium bridges, which is being passed around through here. And we're also giving out 10 Arduinos and 10 Helium Arduino shields. We're breaking ground in San Francisco and building our first metropolitan network. And we want to know if you're in. We want people that are in on this. And one thing we've learned is that details details matter when you're building something, and it's always worth getting it right. And that's what we're really trying to do for Helium, is we're trying to build something that, maybe not right now at the moment, but a couple of years from now or a few years from now, the long-term goal will be solved in actually creating connectivity for the world. And that's it. Thank you.
Thank you very much. One question over there. So it looks like your, name is Nathan Mariash. I'm a consultant in the hardware and kind of offshore manufacturing space.
Sure.
I had some questions about how your service, are you looking at a service model with this, and how does it compare with, say, an AT&T or Verizon data plan? What is your pricing model for that?
Sure. Good question. We've actually tossed this around a lot. And one of the things that we've thought about early on is we want to make it free. Sorry. We want to get it. So one of the things we thought about was making it, for public access and public usage, it doesn't cost anything to use. And from that model on, if you actually want to make money off of it, it would be some fee per device per year. And the idea, like I said, it's not about having that stream of connectivity. It's about your pet rock. And your pet rock's not that important, right? But you also want your pet rock to be able to update his Twitter account sometimes. And we want it to be that cheap. We want it to be, there's no way. So if you think about IoT, 25 billion devices, like with the current cell phone models and the current part of, this current existing world, how do you connect 25 billion devices when it's still, the barrier to entry is $20 a month? It's just not possible. And that's the problem that we're trying to solve, is we're trying to make it pennies, not dollars. Right over here. Oh, another one here.
Ted Ulrich.
Hey, Ted.
So is it Zigbee, or is can you just talk about the chip?
Sure. So the protocol is not Zigbee, but it's based on the 802.15.4 frame, which is what Zigbee uses. The reason why we chose the 802.15.4 frame is we wanted to make it so any Zigbee chip could eventually be ported to actually use this protocol. But it's a custom star topology protocol that we've created. We call it Helium protocol. It's kind of nice, well suited. So it's a star topology, but eventually in our next phases, our Helium bridges, what you had in your hands a moment ago, those bridges will actually be able to mesh to each other, but they also speak to an edge-enabled router that lives on the internet.
One more.
Okay, I'm Doug from Electronics. Question about home automation. Is there encryption or security on the device itself so people can't spoof me?
Yes, sir. So that's kind of the backbone of our design. Have you heard of an AT SHA 204 chip? So the backbone of our actual hardware, the initializing the hardware itself, it's initialized through a chip called the AT SHA 204. That chip actually holds a SHA-256 hash that gets a generated session. I'll try not to bore everybody with this, sorry. But the idea is you can actually create sessions based off this chip and then actually intercommunicate with our routing platform securely using ACE-256. I think there was one general here.
What percentage of that data would be encryption?
Everything's encrypted. The only thing, oh, go ahead.
What percentage of the overhead? You have 160 byte packet, right?
128.
So how much of that would be encryption?
So the only thing that's not encrypted are the headers. So the actual header, the destination headers, but the actual payload of every packet is completely encrypted. And the actual payloads that live within the payloads can also be encrypted by you, so Helium can't actually see it either. So not only do we want to encrypt our own data going to the network, but we also we can make it so you can encrypt your own data so Helium doesn't know what it is.
But then how much less data do you get across security because of the encryption?
So one of the things we've done in Helium is you can actually do multi-block transfer. So the frame size is only 128 bytes, but you can actually do multi-block byte transfers on our 802.15.4 firmware. So you could send as much data as you wanted. It just depends how many years you want to wait for it to kind of get up to the network. But it's one of those things where if you're sending small pieces of data or small blocks and chaining blocks together, you can kind of get away with it.
Thanks.
Yep. And it's symmetrical, by the way. So We're not trying to do like a whole 20, 48-bit cipher or something.
Actually running a little ahead of schedule, so I'll give two more.
Hi, Aaron Franco, CTO of QuickSlide.
Hey.
Yeah, it seems like a developer, kind of like a developer-centric approach. And I was wondering if you could talk about like the workflow of like developing applications on top of Helium and how that might play out for someone, for a developer or a company.
Absolutely. So we've recently integrated, and I believe you raised your hand about Node-RED, correct? So we've recently integrated Node-RED for one reason. Helium has, and if I went back to that architecture diagram, Helium's a router and a set of bridges. When it gets to Node-RED, we're doing interesting things with Node-RED where not just the back end is Node-RED anymore, but it's actually Helium, and it just looks like Node-RED. And the idea is that that whole back end and that whole flow can be controlled by you or us. So we'll have a hosted instance of Helium where you can create your flows, create your instance of application and run them, or you'll be able to fork what we have and then run them in your own instance and actually process messages from Helium and work those messages. The router is there mainly for security and understanding the scope of your devices. So the idea is you could have 1 million devices, and we have this distributed system that can actually correlate and figure out when you want to message 1 million devices or you want to update the code on 1 million devices, we can create that. We also have a C library right now that uses message pack for handling messages. And the idea is the message input or the incoming messages are just there to be parsed and figure out what they are and then actually create a flow for those messages, and you can switch on them whatever way you want. And I would love, we could absolutely walk through it and show you, but the idea is we want to make it really, really easy. So very little code, like you saw in that demo, the C hello, I press the button all the way to the internet where there's no TCP, no TCP, and it goes all the way to the internet.
Yeah, Sean, Rich Rodney, helping run the NYC EDC Next Top Makers program.
Hey, Rich.
You mentioned that you're launching first in San Francisco. What are your plans to come to New York City?
Yes. yeah. So our plans are New York and Boston. So New York, Boston, LA, Chicago. The idea is we want to make coverage for 20 million people. I think there's 5 million people in the city, 8 million people. Yeah. So this would be a next best guess. There are with RF and different frequencies. It could be hard or easy. Actually, Mark, who's over here somewhere, he was like, so when we shoot a radio wave down Times Square, what's going to happen? I was like, I don't know, all these neon lights and electricity and all of these things change, right? But there's no trees, so there's no watery leaves soaking up 2.4 gigahertz. So there's a lot to figure out, but New York is definitely in the running of the top 3 cities that we want to deploy into.
Great. Thank you very much.
Cool. Thanks, guys.